I don't really live stream myself programming on YouTube anyway.
You live stream programming on YouTube?
I program and I live stream it to like Twitch and Discord and YouTube simultaneously.
What kind of viewership do you get on programming live streams?
10 to 100, like
10 to 100?
Yes, that's the viewership.
It's not bad.
Yes.
What do we get for people watching these?
Yeah, we've done 0. 1.
Usually one.
But it's like I'm on a Zoom call with Sophia at the same time.
So yeah,
call
good,
like,
good.
and see, oh, am I making mistakes?
We don't really show off the live streams, but it's more about like how many views do they get. So
I mean, this isn't really a good format for watching after the fact.
not really, unless you want to just kind of sit with it in the background. But
Yeah, but then you're not really paying attention. You're just
the first one we did a month ago has 46 views now. The next highest I think is 20, 12, 14, kind of that range.
okay. So I'm going to go into this one and then share my screen because I can do that now. Cool. Here we are. If people have WhatsApp, we're going to try out WhatsApp for a bit. So that we
You
can
can
do
message in the
this.
browser record.
Do you guys want to? Do you guys want to scan that?
Okay, sure.
You ping.
Oh, you've already joined WhatsApp, yeah.
Oh, should I join?
Yeah, if you want.
Your screen there.
How does that work? Do I just wait?
You can scan it with anything.
Wow.
Oh, was that stream?
Josh, can you share the live stream link in the group chat?
Yes, that's a fantastic.
So we have the live stream link, but we also have the link to join in the call people now.
Share that as well.
So phone number privacy, it's in settings for the community. You can make it
The fact that it's not on by default is a little interesting.
have the privacy type phone number. It doesn't necessarily leak. It's just like if you haven't set that up.
Okay, cool. We're
So
getting
they're joined now. That's it.
to it. Let me stop some more cheese it's in my face. Yeah. Hello, everyone. So today we're going through the paper, The Surprising Effectiveness of Test Time Training for Abstract Reasoning. This is a paper that has had a lot of attention recently because it got higher than the average human on the ArcAGI like abstract reasoning test. And I know we went through it last week, but to go through some examples of ArcAGI. Does everyone here know what ArcAGI is?
That's the one by Francois Chalet.
That's the one by Francois Chalet. So we've got this, where we've got input-output pairs, and they all sort of follow a similar pattern. And yeah, and they get more difficult as time goes on. This one here, like, we can see we fill in these corners here. And then we can submit the solution here. Historically, AI benchmarks are terrible. Like, one of the reasons why this was created is because Francois Chalet's argument against a lot of other benchmarks is that they're very susceptible to memorization. And so because they're very susceptible to memorization, you get these sort of spikes in the performance where like the benchmark is introduced, all of a sudden like models just exponentially go like so much better on them. And then after they get to human capability, they sort of teeter off. I'm not sure if that's just because the developers stopped putting effort into making them better at that, or I guess it approaches 100%. So then it just gets less good. ArcAGI was created before LLMs were out. And yeah, there's sort of the idea is that even if you have a lot of the data of the test set and everything, the new tests that can be created are so abstract that they don't really help you if you're not doing abstract.
You mean 5 years ago it was created?
Was it created 5 years ago? Yeah, before GPT, before ChatGPT was released.
So how does understanding the pattern of pictures get generalized into actual reasoning? Like, I get that the pictures are reasoning, but how do you take a model that can solve this and apply useful real world stuff out of it?
I think it's the other way around. You make a model that can solve general real world stuff. You prove it's good by having it solve this problem.
Yeah.
But it's, especially if you've got a huge CAF prize behind this, like people are going to optimize it for
Yeah, but
solving these problems.
Francois' sort of thing is that if you are able to sort of solve that, you have more than just like
Like, is there, I guess another way of asking the question, is there a way of turning general reasoning problems into a format like this?
well, I guess Francois' argument is that general reasoning, if you had general reasoning capabilities, you would be able to reason about this.
Well, what you said, the answer is no. There is no way to turn something in AI that can turn, like, solve these weird logic puzzles into general AI. But the approaches, and like including the approach we're looking at today, does involve taking large language models, which are kind of like a generalized artificial intelligence, and applying it in a way to solve this problem. Like, this is general. Like, the method this paper describes does generalize beyond just ArcAGI.
Yeah.
So, like, empirically solving ArcAGI, you do that by having a general method.
Sorry, what is the method that the paper describes?
That's coming up soon.
Okay.
So that is ArcAGI. It has been a little bit more resistant to memorization. So, but apart from this recent jump up here, and I guess the one that just got released last year. We have, like, ever since they put more money behind it, there has been a lot more jumps in performance. But yeah, the surprising effectiveness of test time training for abstract reasoning. I'm going to start now. Language models have shown impressive performance tasks within their training distribution, but often struggle with novel problems requiring complex reasoning. We investigate the effectiveness of test time training, TTT, updating model parameters temporarily during inference using a loss derived from input data as a mechanism for improving models' reasoning capabilities using the Abstract and Reasoning Corpus, ARC, as a benchmark. Through systematic experimentation, we identify 3 crucial components for successful TTT: initial fine-tuning on similar tasks, auxiliary task format and augmentations, and per instance training. TTT significantly improves performance on ARC tasks, achieving up to 6x improvement in accuracy compared to base fine-tuned models. Applying TTT to a 8B parameter model, we achieve 53% accuracy on the ARC's public validation set, improving the state of the art by nearly 25% for public and purely neural approaches. By ensembling our methods with recent program generation approaches, we get state of the art public validation accuracy of 61.9%, matching the average human score. Our findings suggest that explicit symbolic search is not the only path to improved abstract reasoning in neural language models. Additional test time applied to continued training on future examples can also be extremely effective. So, a couple of things in this. One of the things that is pretty crazy about this is that they are able to do this with they do a lot of tests with a 1B model, but the final thing is only with an 8 billion parameter model, which is not very high at all. When it comes to the methods that they're comparing to, they do a explicit symbolic search. They're referring to generating like a piece of Python code that solves the problem versus a neural model which then just outputs the final board state. So in this, they're outputting, they're like outputting the final state, as opposed to a lot of other solutions, which will generate a piece of Python code that then generates the output state. Yes. One of, so if people have seen the example before, this is one of the examples of the sort of, yeah, the incorrect predictions with just standard fine tuning, versus the test time, like training approach of this. And like, just, I mean, quickly.
What is that question?
This one here. I am not completely sure, honestly. It does look like the diagram is basically broken, doesn't it?
I think there's some logic to it.
So to be clear, I think the top row and the bottom row are different puzzles.
Oh, right.
So there's the top row.
Yeah, so
which shows one example, and then the test.
yeah, and the filled out thing. So it's giving one example, two example, and the test example.
I think it's a little different. So the one on the top, very top left, that is the example input. The next one is the example output, then the test input.
No, I think this is
Each column is a separate test.
Yeah.
Oh, that makes, sorry, yeah.
So these are these here are the
So
incorrect examples.
It's the outer corners turn yellow and the inner corners turn red. That's what the test is.
Yeah, and then the test here, and then here we have the model predictions.
How many examples are there?
In the actual test cases for ArcAGI, you get 3 full examples and 1 test. With this diagram, we only get 2 examples. And 1
There
test.
are rules you could learn which are consistent with all the examples, right? So there could be multiple correct answers rather than just one.
Yeah, I think so, but I think
If there's multiple correct answers, it's a problem with the data set.
yeah. I haven't actually gone through the original ArcAGI paper or anything, so I'm not completely sure.
But no, the logic problem should have a single possible
Yeah.
answer,
Yeah.
right?
Yeah.
Otherwise, it's a failed logic problem.
Yeah, so I guess this is I'm going to do the introduction, and then I'm going to move on to the contributions, and then get into these parts, and then talk through the experimental setup. The experimental setup is interesting because it shows how they got more training data from the small amount of examples that they had.
How will the humans do it?
They do like around 61.9%.
Is that trained humans, like expert humans, or like
I think that's the average human.
average?
Large scale neural language models, LMs, excel at performing tasks that occur in their training data, and often elementary variations or compositions of those tasks. Given natural language specifications or a small number of examples, LM often successfully infer the desired task and produce an appropriate output. But LMs also solve new problems involving non-trivial reasoning, but can LM solve new problems involving non-trivial reasoning, planning, or string manipulation of a kind very different from their pre-training data? This question is central to understanding the novel skill acquisition capabilities of current AI systems, which has been proposed as a key measure of intelligence. Here, so what the experiment that they have done in this paper are FT, which is fine tuning. So essentially just a whole bunch of these examples. And they have TTT, which is adjusting the weights at inference time. We can see that with fine tuning, we only get a small accuracy update. And with test time training, we get a much larger, so like 45% for fine tuning and test time training, which is interesting. Moving on, I'm going to skip over to this here. We identify several crucial ingredients for effective applications of test time training to few-shot learning. 1, initial fine-tuning on synthetic tasks similar to those encountered at test time. 2, an augmented leave one out task generation strategy for constructing test time dataset. And 3, per instance, adapter training. And 4, self-consistency approach under invertible transformations. With careful choices of these components, TTT can significantly improve LM performance on ARC, increasing accuracy by up to a factor of 6 over a 1 billion model, and achieving state-of-the-art results for published purely neural models on the ARC task with a 8B model. Indeed, our results show that when equipped with test time training, ordinary LMs can match or exceed performance on many neurosymbolic approaches on ARC. With this, we have the contributions, which are we identify and systematically analyze the key components needed for test time training on ARC tasks with a novel test time training data generation and self-consistency component. We achieve state-of-the-art results among published neural approaches on ARC validation set. 53% accuracy on the public validation set with an 8B parameter model, and 61.9%. So this ensemble with program synthesis approaches matching average human performance on the data set. And we demonstrate that the tasks could only be solved by program synthesis previously can be solved with fully neural approaches equipped with our TTT framework. Does anyone have any questions at the moment? Questions, queries, comments?
So you need to understand, when I say test time training, does it mean they're not actually updating the weights after they've trained it, right?
So they do full fine tuning. No, they do fine tuning. I think after they do fine tuning, they then use the things at inference time to make a LoRa adapter.
Oh, okay.
Out of the examples, and that is the test time training. When they mean training, they do actually mean updating parameters.
Okay, yeah, wow, I didn't realize that from what you said so far.
Yeah, yeah, exactly. So I'm going to the ARC challenge here. We already sort of went over. In context learning and test time training are the interesting things. I could read this, but yeah, I will go over the I think to begin with, it's more interesting to go over the experimental setup of how they actually end up generating the like these results here. So fine tuning is when, so this part here in the results, fine tuning, they're doing fine tuning on a bunch of examples they've found. When they generate the data, they are going through this here. So this diagram shows that you're given 3 examples with the corresponding answer. And then you're given a question, X3, and then you're asked to generate the solution to this. There are 3 things that happen. One of them is we do a permutation of this. So here we can say that we're getting X0, Y0, X1, Y1, X2, Y2. We're then using this to then create 2 different examples, and then we're leaving this last one out. So we want to guesstimate, we want to estimate this final one. And
I think essentially what it's doing here is you have one task from the training data, And you want to have a lot more of them because it's better to have more synthetic data to train on. So this is essentially this is completely specific to ArcAGI. It's not general intelligence at all. Like if you got 4 examples, then you can generate like a bunch of 1, 2, and 3 by just using all the possible combinations of those. And then you can make even more examples by flipping it horizontally and vertically, which is just way essentially to expand the set of the training data.
Yeah, and so instead of only having 3 examples here, and then we're getting the other one, we're actually getting what a permutation of 3 examples. So we're now getting significantly more because we have all of these ones here. And then yeah. Let me see. I actually did generate. I did go to that one, Excalibur. I'm contemplating whether I need to actually read through this, because some of the math things are sort of confusing. Does anyone? Do people understand the idea of taking the 2 here and then recombining them?
Recombining them how?
So we're essentially going to so usually the problem is that like you're asked to predict the 3rd one here. So given these patterns, what is the rule, and apply it to this to get the transformation out.
So you'll have like taking it in as a 3 by 3 matrix, and then you have some representation of it, and then you're trying to find out like what is the Einstein transformation of like, okay, fine, this is what you're doing over dimensions, how they're like rotated and shifted, or is it more like you're taking in a pure image and then based on the image it's predicting what the output is? Like, do you get a structured representation, or do you just get the image?
You get a JSON representation.
Okay, what does that data representation look like? On screen, I just have the.
Oh, if we want to go, actually, we don't even get, if we want to look at the representation exactly, we get this.
Okay, so it's a grid of numbers.
It's a grid of numbers. The numbers represent the colors.
So like it's a single integer for a number. It's not like RGB code.
No, yeah, it's just a single integer.
If humans got the number for it, that would be more difficult for them to like find it, because colors is like makes it easier.
Yeah.
So in the paper, if you're seeing in the figures the colors, that's going to be an easier problem than if you're seeing it purely in the structure format which the model is getting.
Yeah,
so it's like sort of a different test.
Yeah, I guess it is. But I guess it's still like if you just go to like reading numbers or something, I guess it would sort of be the same difficulty. So section 3 is what data set and loss during test time training. 3.1 data generation. Given a task, we take the set of training input-output pairs and turn them into an augmented set of test time training tasks. We obtain DTT. We obtain DTT using a 2-step process. First, we create a set of leave one out in context learning examples from the given training input-output pairs. Secondly, we use invertible rule-based transformations on this set to obtain an augmented data set. This process is summarized in Fig 2. That's the one that we saw over here. Step 1, leave one out tasks. By excluding the jth example pair of the training examples, we can create the following synthetic task. I am not going to read that.
I don't think this section is particularly interesting, like, this isn't about how do we make.
It's
AI.
how do we make more?
This is specific tricks on how you can do better on RKGI, which is less interesting.
Yes, yeah, that's a good point. I think we should probably skip this. But the point of this is to make a lot more examples. So because we have 3 examples, we're taking the examples and then we're horizontally flipping them. So we're doing a transformation, and then we have, because we have the identity, we have the horizontal flip, and we have the vertical flip. And so we've got like 3 times as many pieces of data to train on than we did if we were just using the raw thing. Does that, are there any questions, queries, comments about that?
I'm setting up the repo now because they have the link to implementation in.
Sick.
So I have some in like 30 minutes.
Yeah. The thing that I want to get to on this is how the actual LoRa adapter ends up being applied, because what ends up happening is, so we have this where when we generate our data, we generate our data like this. So we have our test. If we can see this, we then make a prediction. And then we get the loss between the prediction and the actual with all of this in context. So with our language model, we get our language model, and the input of this would be these. And then with the third one, we then are given a like we're told to make a prediction. Hello. The important thing to note is that this is the demo. This is in the paper. This is called the demonstration loss. So the reason why we did all of this to generate all this data is so that we could have as many ones of these as possible. So we're taking our original test task in context. We're then getting these different things, and then we're calling the language model on these 3 examples, and then we're getting the prediction for this final one. And then because we already have the final one, we'll get the actual. We'll get the actual prediction, the prediction, and then we'll get the after that we'll get the actual of this final prediction here, and then our loss will be the difference between our prediction and our actual. So you said before, like, the grid is a bunch of numbers. So does that mean, like, if you're 1 color out, then it's closer than if I was like 3 colors away? It's a loss between the tokens.
Okay.
So it'll be they're represented in like different dimensional, like, because that's at that point it's just standard next token, like a token loss between the thing that you expected to do and the thing that you actually wanted to do. I would suspect, yeah.
Like a blue and a cyan, which is far away. Right?
Yeah.
Okay.
Yeah. So the thing to note about this is once we get this loss, this is all happening in context. We then take this loss and then we create a LoRa adapter for that. The reason why this is interesting is this is happening all at inference time.
So what is a LoRa adapter?
A LoRa adapter is a way of doing, I have done this here. A LoRa adapter is a way of doing a fine tune that you need to adapt. You need to update a lot less weights than you do with a full one. So if you're doing low rank adaptation, so you're essentially getting two matrices that approximate the larger matrix, and then you're changing each element of the smaller matrix as opposed to each element of the larger matrix. The reason why that is if you, with language models and the features that they learn, if you consider, 1, 2, 3, 4, or let's do it really easy, 1, 1, 1, 1. And then this is like 2, 2, 2, and 2. And we do that again. 3, 3. Actually, you know what? I can just ask Claude.
We've lost the ability to memorize numbers. Are we going to lose the ability to draw?
100%.
I think we've already got handwriting's totally done.
Sorry?
Yeah, Claude didn't give you a React component. It tried writing a Python.
Yeah, okay, it's also, at least it's doing this now.
Hard to see. Can you zoom in a little bit on that?
Yeah, that's true. No, it's that one. Nope. Zoom all the way in. Did that work?
It's okay.
That doesn't really explain it very well. No.
But it's pretty.
Yeah. I guess the basic thing behind LoRa's is
And LoRa stands for low rank adaptation, right?
Yeah.
It's a fine-tuning method.
Yeah.
What I thought it was just changing the weights that are at the end of the process.
Well, the reason why you do low rank adaptation is because I think it's because particular rows in the matrix end up being like scalar multiples of other rows, and so then you can decompose it into smaller. Because like this row here is,
the three of them are all equivalent.
yeah,
If you think of a matrix as a linear algebra solution where they're just solving, they represent equations.
yeah,
To say 1x plus 1x plus 1x plus 1x equals 1y.
yeah,
Or I guess it's 1x plus 1y plus 1z equals 1a or whatever. Like, to have those three rows in a matrix, they're all equivalent, and you can't really solve the matrix that way. Now, I don't know how that ties into the use of matrices in a machine learning model, but
Could that be the representation of the problem? Just because you need a mathematical representation of the problem? Or am I?
yeah, but what I'm getting at is you could, when it comes to matrices in linear algebra, you can always arbitrarily add new rows
Yes.
by doing those combinations. And how does that impact?
Yeah, would it be reasonable to interpret like the matrices that represent the weights of models as systems of linear equations?
But yeah,
I don't think so,
that's
but maybe you can.
especially when you do the non-linearities. There's obviously more to it, but and I guess the order matters too. Yeah, I guess they're just matrices without being.
is this gonna work? Oh, here we go. There we go. Okay. Yeah, so this is low rank adaptation. If we actually do this and go here, nope. Why do I keep copy link? This one here. So here we've got the larger matrix. One of the things is that you can see this larger matrix, like, you know, 2 is the second row is a combination of the first row, and the third row is also a combination of the first row. This is like grossly oversimplified, but you can decompose this larger matrix into other into 2 smaller matrices. One of them representing a column matrix and a row matrix. And then when you're doing the fine tuning applies to these elements here, not to these elements here. So essentially what this is exploiting is the fact that once you've pre-trained a model, when you're fine tuning the model, you're essentially pushing the model to generate in a particular distribution of the model rather than changing all of the distribution itself. This is one of the reasons why pre-training is often named distribution building, and fine tuning is often named mode seeking, because you're not actually changing a whole bunch of the internal distribution. You're essentially just adjusting some of the rows in there so that it can generate in a different part of it. Yeah, and there are significantly less weight updates that you need to do when you're doing these 2 changes than when you need to do this change here.
So you're just updating the column and the row vector matrices?
Sorry?
You're just updating the column and the row matrices instead of the cross product?
Well, you update, like you do gradient descent on this feature here within the model.
Yeah.
This here in the model, and that ends up changing a number of things within here, but you don't have control over changing every single one of those.
So how? This is probably getting enough route. It's like you have to update 7 weights instead of 12.
Yeah. One of the reasons why this is done as well is if you end up doing too much fine tuning, full fine tuning, you end up having model collapse because the internal distribution of this ends up tending to collapse towards your fine tuning data set, and you end up because like the loss in between when you're fine tuning, if you can basically overfit your model to your fine tuning data set, and this is not, you have less of a chance of this happening when you're doing low rank adaptation, and you need to update less parameters.
So why don't we train the models to learn these in the first place?
Because these are because they're like, why don't we train models with low rank adaptation to start with?
Yeah.
Because they're all zeros.
So if you randomly initialize your A and your B here, and say that the model in the forward pass is using the product of B cross A,
Yeah.
but then as you're doing the backprop, even from random weights, just update B and A in the beginning.
Because then like there's no distribution that you've built up to actually be able to sort of adjust as a random distribution.
Yeah.
Yeah.
So why aren't open source models distributed in LoRa format?
Because this is an oversimplification, because you often
Okay,
have
so this reduces performance.
it reduces precision because there's like an error that comes with that. So you still need to ship all of the weights, but when you're doing the adaptation, you care less about the adaptation than you do the underlying weights. And so if you go to Hugging Face,
So I guess this makes it easier to find tune at the cost of a little bit of working work.
but you don't care about that for LoRa's, like low rank adaptations and everything.
Why don't you care about that for LoRa's?
Because I guess with that you're doing because you're changing.
Sorry.
because like you're sort of changing the internal distribution just a little bit when you're doing fine tuning.
Okay,
And so if the little bit has a little bit of error as well, it doesn't matter as
Okay.
much as if the bottom distribution.
actually, because this is only used to essentially get a diff and make changes, and we're not.
Yeah.
We're not completely losing it
Yeah.
as soon as we do the LoRa.
Yeah. And so a lot of like I'm not sure if I have any, but there is some of them on here which has like some of them will be no, they're complete ones, but you'll see on Hugging Face you'll get like a .LoRa thing that will end up being the
The lures are pretty common in the image generation tools.
Okay, so they are actually just as LoRa.
yeah, and the good thing about that as well is they're significantly smaller than
Yeah.
the base model. So you'll often find when you're fine tuning and uploading stuff to Hugging Face, it'll actually tell you if it's a LoRa because it's as a much smaller file than
The part that I missed that I think you mentioned is that the LoRa file that's created from your row and your column create a matrix that's added to the real weights.
Yeah.
Rather than replacing the real weight for the original weights.
yeah, because then you're just doing combinations of the base thing. Hello, new person as well.
Hi,
Hello, I'm Josh.
I'm Mara.
Nice to
Nice
meet
to meet
you.
you guys.
I did see you registered like 20 minutes ago or something, and I was like, nice.
I was invited
That's
last
great.
week after last week,
That's great.
but yeah.
Well, welcome. I guess a getting to know you question that we've been doing for the last 2 weeks is what's your favorite Taylor Swift song?
That's a real question. That's a real question.
My one's New Romantics. I'm sorry. You don't need to answer. We can continue.
I don't know how to respond to that.
Oh,
That was like,
Yeah, the same question. It was awkward for me.
you know what?
that
I
was like a 5-octave dimensional drop from what we were doing to that.
Major
question.
context switch,
So,
yeah.
so I feel like.
It's just, we're gonna just do it.
Okay. I one of the things
What did you ask?
If he's on a call and need yours though.
one of the things that I realized is I can add that as a required question in yeah. And then favorite hey
No.
song. Required. There we go.
Required.
Smitty doesn't need to answer it because he registered
Like,
for all of the
spot
events.
Two steps ahead.
They won't let me in next time.
Okay, so let's go back to here. Do you have any questions about the paper so far? Like what's going on or anything like that? Okay, cool.
Yeah.
Have you printed it out and everything?
Yeah,
I'm impressed.
I was.
That's great.
I'm old, I'm not a computer. But I was premeditated to this.
That's awesome. That's great. Yes, so they're LoRa adapters. Are there any questions around where they're like sort of what the process of doing that is and like applying them?
Does anyone have a GPU I can access session to? Because my GPU
Chris does.
is screen here.
Does an M1 count as a GPU?
No.
Okay, then no.
I don't
Yes.
think they work.
Uh-huh. So I went through LoRa. Does LoRa make sense to everyone? Okay. I'm going to go to so we went through the data set and lost stuff. The optimization objective one is goes over LoRa. The training objective is or sort of what we went over, where we're minimizing the loss between between the things here. These here's the ablations of the paper. So what they end up doing is they end up having a couple of different experiments. And I will go over each one of these in the results. I'll just start reading from 3.3. Results. We compare the main implementation of our method to the following ablations. FT, so fine tuning, no test time training. The vanilla baseline where test time training is ablated and the fine tuned model is used instead. 2, no transformations, no transformation based data augmentation. That is data from step 2 of the data generation pipeline described in section 3.1 is not included in the test time training data set. 3, end-to-end E2E data. Instead of the standard in-context task setup, we use the end-to-end task formulation as described in section 3.1. 4, shared test time training. In contrast to learning a task-specific LoRa adapter, a single LoRa adapter is learned using an aggregate data set of all tasks. 5, no demonstration loss. No loss is taken at the demonstrations and the training outputs of the data. That is, TTT loss is simply this. We'll go over what the heck that means. And QLoRa. Rather than full precision-based model updates, quantized LoRa adapters are learned for each task, which is the alternative for LoRa considered for memory efficiency. Yeah, so this, like, honestly, this paper doesn't do a very good job at explaining all of these. I needed to go over it quite a couple of times to actually understand what all of these different experiments were. And so we're going to do this here, where we've got fine tuning, we've got no transformations. Let's not make it. Yep. We've got N to E to E. What is it? E to E. We have shared TTT. And we've got no demonstration loss. Also, like, I need to point out, compared to the other papers, this is a lot more.
This is 6.2, but there's QLoRa as well.
There is QLoRa. That one's easier to. I'll add that.
Have to go back.
Catch you later. Does anyone the fine tuning without the TTT? This is just like sort of train and update base weights.
You need to have a Deloitte employee escort you out.
I don't have to be fast, I think.
No, I mean, I think like you actually.
I just have to give this back.
I know, I'm pretty sure I'm gonna lock you down.
Yeah.
Okay, so I can go find him in the.
No, I mean, like, non-Deloitte employees are not allowed to walk around in this building.
I know the way back, like,
No, I don't think it's a you thing. I think it's a security thing.
Yeah, like, there's a lot to, like.
if I get into trouble, I get into trouble.
I
No,
get
you're gonna
into
get us,
trouble.
you're gonna get us all into trouble. if you
Oh, wait.
go to the Deloitte employee.
Yeah, I think you just gotta wait for a little bit. I'm sorry for you to rush.
Do you have Alex's number?
He'll be back soon. He'll be back in the next 5, I'd assume.
But he was called away on Teams.
He went to just go grab pizza.
Okay, I can create a slice of him. Maybe it's a good idea to wait for this.
Yeah, if you could just wait for,
I'll wait for this.
that'd be awesome.
You know,
Thank
it's
you.
not urgent.
Perfect.
I mean, yes. So this paper is a little weird because it has a lot of technical details, which I feel like I need to explain the background to, but that also means that the presentation is a lot more confusing than the standard ones. Would people like it better if we just read through the paper, or do people like the presentation?
Presentations.
Presentations.
Okay, that's good. Is anyone, does everyone understand what the fine tuning?
It says where TTT is ablated. What does that mean? I think it's the word ablated.
Ablated means excluded.
Oh, okay, got it.
I need to get started out. Like,
Oh, you need to go.
Yeah, I just, like I schedule the time first.
Okay. Catch you later.
Like I live an hour away, so it's like.
Don't worry about it. Don't worry about
Yeah.
it. Don't worry. Oh, you want to throw that out? There's a
Yeah.
cycle here.
Yeah, so, so can I just like walk back or do you need to come?
I need to take it.
Okay, good. I mean,
Okay. I'll let you go on. No.
like I'm going, I just take like one size piece of meat. You know what, why not? I came all the way here. Veg, yeah,
Yeah, I got napkins.
oh, it's got pickles on it.
I think we're eating actually.
You could have just,
No, oh wait, napkins, where are they? Plates,
Thank you.
just go into the room across.
Wait.
Open the drawers and you'll find.
See you next week.
catch you later.
Yeah.
See ya.
Okay.
Have a good one. Let's take a break anyways. We got pizza for everyone else too.
Yeah, let's do that.
We have water.
No water.
Nope,
There
no
is
water.
water.
You have to drink sugar water.
Shoppers closed. There's like a water thing over there.
I've got a saggy water. Oh, would you like some of my saggy water?
I can tell you where it is.
That looks, that looks.
Yeah, sure, yeah.
Yeah, there's like,
Grab a cup, you go out.
there's a big jug, you know where like that copy machine is on the other side of the elevators? Yeah.
How's it going, David?
Good.
It's great.
Very good.
Oh, look, you guys can get up and have
This-
pizza if you want.
I mean, the fact that it's dark right now sort of makes me sad, but
How do you know if it's dark outside?
sorry. Oh, because I can see the outside. Oh. I also assume that it's dark. Yeah. Anyway.
You've seen my office at least once, right?
Mm-hmm.
There's no indication of the time of day in my office.
Some look better sometimes.
So this, my lights are on a time. So I also turn off the lights at 6 o'clock, so I know it's not working. And I inevitably just turn them back on, knowing it's 6 o'clock and working anyways.
Damn. That doesn't sound nice.
Building the dream.
Mm-hmm. Did you end up reading this one, David?
This one?
Yeah.
No, not fully. I appreciate the
You
presentation.
gotta go take those goodies that came off. I just
What?
have your pizza off. You gotta
Yeah, I mean, like,
pick it up.
but like, I get my hands all dirty and like, I have to like round with the box.
I don't know.
Like, I try to be careful when I procure pizza to avoid this, but I'm not good at it.
We're not perfect.
Mm-hmm.
Did you the veggie?
Why?
Good go-to for complimenting your dog.
This pizza is
Oh.
delightful.
That's a knee snapper. Knee slapper.
Hi, Paho.
Hi.
How's it going?
How are you?
Could be better.
Might assume that the events have paused.
Sorry.
You missed Smitty's comment.
Sorry?
You missed Smitty's comment.
Oh, I'm sorry.
Do it again. Do it again.
About the pizza?
Yeah.
Yeah, well, like I was trying to get some pizza and like some of the stuff fell out of the pizza. And it was in the box, but I didn't want to put it back on the pizza. I was like, I'm getting my hands all.
No,
just-
he-
just-
he-
Oh, delightful. Oh, yeah, yeah, I said that the pizza is delightful. I think I've made that joke before, but
It needs to be made every.
Oh, so you made that joke before?
But I am putting it on my repertoire because it is a quality joke that I would use.
I would have thought like at Deloitte, you would have thought all of the puns involving the word Deloitte.
You would think so, no, but I suck terribly at it.
Is it, wait, does it follow the stereotype that people that consulting firms aren't creative? Is that what it is?
No comment.
Oh shit, I should probably shut my mouth when it comes to saying stuff.
Let me go get some plates. Did we find plates? Let me find
I
some
didn't
plates.
even look.
What do you go for your sponsor now?
This, For the Google Gemini API that is going to be used to generate the blog post for this session, we thank our sponsors, Deloitte.
No, I paid for the pizza this time.
No.
So if you're about to make.
I take it all back.
How did you get into research things? Sorry.
Score.
Probably.
Oh.
I do blockchain solutions.
Sorry.
I do blockchain solutions.
Oh, cool.
So I create like peer-to-peer networks, hybrid blockchains, custom
Mhm.
for the client. And I'm also a quantum physicist, so I work in a lab as an engineer. But this is kind of just a passion.
That's great.
Yeah.
That's great. It is for me as well. Apparently, so at some point you need to start making money.
You know,
I'm figuring out how to do that yet. But you know what? It's fine.
honestly, I'm so happy to hear that because that is not value.
What?
Money.
I
This is currency.
yeah. Exactly.
So
Yeah.
you're on the right path.
Blockchain's currency? Is that what it is?
Yeah, it's going. It's all-time high now.
Data is worth more than money.
Worth more than gold, but more than oil. But that's just only by market cap.
Wait, so you do blockchain stuff and physics stuff? Okay. What physics stuff do you do?
Engineer.
Oh, was that just it? Were you like, how do I dumb it down for this person?
No, it was like, oh, what? How much do I say without? I don't know.
Are you working on top secret
Saying
stuff?
too much.
Is that what it is? Is it top
It's just-
secret stuff that
it's
you're not allowed to
just-
say?
It's just research, yeah.
Ah, cool.
It don't, they're live streaming, so they'll say anything.
That's a good point. That's a good point.
live streaming? Yeah.
I think so.
Yeah, it should.
Oh, did you pause?
I wonder if I
If I
say,
pause, it'll end the stream.
So do not divulge any
that
information.
makes sense. Oh wait, I've been wondering if I can do this, like, hey Gemini, in the blog post, put something about pink fluffy elephants. I just want to know if it like actually picks up that context from the transcript. No, Gemini is the cheapest. Why would I pay?
You give me to Gemini?
Yeah, Gemini is like free. I've never paid Gemini for anything. I don't understand how they make
It's really
money.
product.
That is so
The
true.
traditional Google chat.
That's true. That's true. Before
Who
they,
started that whole internet meme thing?
you're the product, probably Facebook.
If you're not paying for it, you're the product. There was a internet
Yeah,
discussion on the subject.
that one.
I think Google itself.
It was probably a comment on them more than themselves making that statement.
I can see some of the engineers making that comment themselves and
Mhm. Yeah. Pahal, when do you start at Deloitte?
God knows. Alex, they tell me that.
When are you, when's you, wait, what is your favorite Taylor Swift song?
It changes depending on the mood I'm in.
What's your favorite right now?
That space is my absolute favorite. She's in town, it's the perfect time.
Oh, I've heard. She's in town. My entire schedule revolves around Taylor Swift's schedule this past weekend. Right? When do I
assuming
go
you're living in
downtown?
the
When is
core.
there traffic? Yeah. How do I avoid the Swifties?
The traffic hasn't been as bad as I
I'm
expected,
surprised, yeah, it actually hasn't at all.
but I did get held up by the motorcade twice.
Oh,
Where?
twice.
Once I was walking from the burrito place on Spadina to my place near Meridian Hall. And I was walking across Bremner at like 3 PM on Thursday. And she was coming, at the same time, she landed from the airport and was coming up Bremner into the loading bay of the station, of the stadium.
On the stadium.
I think I saw videos of that.
When the second time was on Saturday, I was walking back from I walked over to Kate's yoga. Adelaide and John Street. And I was walking along Wellington back home near Meridian Hall. And the police on motorcycles had blocked everyone. She was going from the Ritz-Carlton back over to the Rogers Center.
You're saying it, Ritz.
In a move that surprises no one, yeah.
Don't have ideas about shenanigans.
What, try to
I'm actually surprised she's staying at the Reds.
Which is probably just because it's the closest one.
I was thinking the Fairmont would be closer.
That's true. That is very true.
She wouldn't need it, but maybe it's too hard to set up a motorway there.
They actually went along Wellington, down Simcoe, down Bremner. That was logistically pretty simple.
Yeah.
When you've got the police blocking every intersection for the whole trip while you're going.
Yeah, but in fact, maybe the Queen did not sign off on her taking this. No, I'm not joking. There is a route. No, there is, as far as I know, there is a room at the Royal York that is for the Queen and and her family.
Because the Queen doesn't sign off, because
Okay, the King, fine.
I've stayed in that one.
Still the Queen today?
Yeah.
You stayed in the King's room?
It was the Queen's room at the time, yeah.
Why?
Oh, we do now.
This was, yeah, no, it's just a hotel room. It's not, it doesn't belong to the royal family.
But they could use it anytime they want.
Yeah.
But they don't go to Canada a lot, so they, in practice, I don't think it matters.
Probably the presidential suite or something.
The royal suite.
Yeah.
Yeah, because we're, I don't know. No,
Fair
the
point.
other one. I guess I wouldn't be surprised in the next 4 years if things got renamed from the presidential suite to the royal suite in the US anyway, but
You know what surprised me about Taylor Swift? And in hindsight, it shouldn't have, but it did surprise me. She has her own car here.
She has her own.
Car. She flew flew private jet into Pearson. And then somebody had driven her car, which was
Driving her car?
somebody else drove her car. So she can take a car with Tennessee plates from the airport to the stadium to the hotel.
Security.
Yeah.
oh,
Security.
that makes sense.
I don't know, but like heads of state don't do that. Somebody drove her own car from Tennessee.
And heads of state, the cars in the front.
No, because I saw Macron's motorcade. And those were all blacked out police Suburbans with Ontario plates.
But I guess it's,
They don't have, I don't think Swift would have access to that. So she'd have to rent a regular vehicle and there might be security concerns.
interesting.
So it might be just easier for her to bring her car in. The US, as far as I know, the US, like the US delegates would bring in their own cars.
I mean, to be honest, who I like, if we were to argue about who had a bigger impact on the state of the world, Taylor Swift or Macron.
It has nothing to do with impact and everything to do with security risk,
That makes sense.
right? There's a perception component. I think the Dutch president rides his bicycle to,
Yeah.
at least from a social meme perspective, but it's the risk and the exposure that is more of. There are people that are a lot more important, but that are unknown that travel very, very safely
Sure.
by themselves.
Sure.
It's, the fact is there's a pandemonium around her and
Yeah.
you have no idea if the car rental company will bug her car just because they can make a buck off of it. So it's just easier from a security perspective to have somebody bring her car or bring some type of thing that is known pre-secured, because she probably doesn't have access to heads of state type of equipment.
I mean, I don't think car rental companies would want to rent to Taylor Swift. Like, you're gonna have a lot of fans, and like, there's lots of risks there. And like, how do you get insurance for like? If I was an insurance company,
You wouldn't want to reinsure it.
yeah,
That was the other thing is I thought there'd be people screaming as soon as she
Yeah,
showed up, and they're
exactly.
not. Everyone was just quiet. They don't announce her, like it's, if you put two and two together, you realize who's in the car, but it's just police blocking and people driving.
yeah.
She doesn't sit there with the window open.
It's probably not pre-announced for that reason, so nobody knew.
Everybody knows that she's got to get to the stadium.
Yeah, but I think if they
Where
just
she-
got
There
a
were people waiting, just nobody was screaming.
if they just got a commune auto and put her in that, I think that it means so much easier. Because with commune auto.
That's the thing, is you could. You just rent a car under the like, local assistance name. And the car company doesn't know it's for Taylor Swift,
You'd be surprised how powerful the internet is.
I guess.
So the good question is, who here is down to go to Ritz?
What are we doing?
Whatever we did that day in by Boston,
What are we doing in Moss Park?
but we were trying to find a random
Oh,
shenanigans.
we, yeah, we never did any shenanigans there.
I think the Ritz, it feels like the Ritz paid her to do it.
That makes sense. I would, if I was a person that could get paid to stay in a place, I would also get paid to stay in a place.
Ritz is.
I'm sure she had good.
Maybe she always stays at a Ritz wherever she goes. Home of
It's a Marriott property.
Yeah, she went back to Nashville.
She what?
She went back to Nashville.
She went back to Nashville.
Or used to stay in Toronto for the week.
Yeah.
Yeah.
It's a logistic
Wait, really?
nightmare.
She actually left Toronto?
Yeah.
It's a
A private
logistic
jet, of
nightmare
course.
Doesn't
when she's
she-
on the road.
I feel offended for some reason. Then she came to my city and she left and now she's gonna come back.
Well, she has 4 days. That's a logistics nightmare,
Yeah.
Yeah.
Oh, to stay in Toronto.
right? Like, if she had a house on Bridle Path, fine. But everything else, in my opinion, at that celebrity status would be a logistics nightmare.
Yes, true.
Right? You need a physically secured compound, given her status. 10 years from now, but no matter anymore. But right now, it's a logistics nightmare.
So she flew back to thing and then she's gonna fly back to, when are you going to see her?
Saturday,
Nice.
You won the lottery?
I won the lottery. It's been a year and a half.
Can you do me a favor and get sick?
No.
Is it the margins or is it the
Keep your
ticket?
germs away from me. That's why I'm saying so far.
Wait, do you have your outfit ready? Is the
No.
question.
No.
What
It's
outfit
so
do you
like
wear?
glitter everywhere?
You wear
I
okay
also
for concerts?
glitter
Yeah.
everywhere.
Okay. I'm just waiting for the glitter.
Just Taylor Swift
Sure,
concerts.
My cousin.
Can you please show pictures? I actually want it.
Yeah, sure.
Will you be at the concert as well?
Like telepathically, yes. Yes, I
In
will-
spirit, in
I will
spirit.
live vicariously through her and the glitter.
Can we get me as many friendship bracelets so I feel like I've been there?
Mhm.
Thank you.
Who was it? Oh, I was at the Brunswick Hotel Victoria on Young Street. And they had a friendship bracelet station. They were just making friendship bracelets in the hotel lobby.
That's 50s for you.
And the space bar, we had a meeting there, they were like 30% off if you have a friendship bracelet or 20% off.
Oh, really?
Yeah.
I have a friendship bracelet not from Taylor Swift. Can I still get a, where's this?
Oshgrove Space Bar.
Oh, cool, sick, that's great. I've been there before.
I think the most hilarious thing about the whole concert tour here is that outside the Rogers Center, they have trailer after trailer after trailer of toilets. And they're all women's bathrooms,
Yeah, it's because
because they never built that stadium expecting it to be like 80% full of women.
Really?
Yeah.
Fair point.
And yeah, that makes
And it's
sense.
completely full.
Wait, like in the stadium, do you need to go out of the stadium to get there?
That's what I'm saying. There's extra bathrooms parked on the sidewalk just for extra women.
Yeah, that's,
Before
Yeah.
that.
Yeah.
well, it's like if you go, if
No,
you go around,
That, I would say, and of course, she can afford the best logistics people, but that's a lot of forethought in logistics.
I mean, I guess when you go to the like 150th city, you're probably get really good at stuff like
yeah.
this.
But in all likelihood, I don't know if this is a reaction.
And people complaining, or just like the city, you know, cholera level spiking when people like
No.
start pissing on the streets.
No, it's just,
Thing.
I mean, you get complaints on social media and
Yeah,
there's no
sure.
point in that.
Well, apparently someone died in Brazil because at the concert.
I don't know. And
Why?
From excitement?
you open up
From-
Monster and then
That's-
it's.
Oh, that.
That's also not that bad. Of all the 2 million tickets,
It's Toronto.
a million,
I thought I was
300,000 tickets alone in Toronto.
What is capacity? for the-
50,000 of the Rogers Center.
During, I thought it was more.
I think it's a little bit more because they put people on the field.
Yeah, because it's 55 without the field, isn't it?
Something like that, yeah. I don't know exactly what it is, but it's a good point about people on the field. So I don't know.
The Stones got to like 80.
They'd be maxing that thing out.
Silly Taylor Swift would also be maxing that out as well.
Well, it depends on how they set up the.
Well, maybe they do, I don't know, maybe they sell, because if she's already doing a bunch of tickets, I mean, maybe the risk is too high to completely mix it up. I don't know.
So it's 50,000. Yeah, because they redid the seating and now it's lower. It's 50,000 without. Here's my curiosity. How much the box cost?
Box seats.
Yeah.
Oh, it's like 10. 15,000.
More probably, more than 10.
No, dude, it's
whole-
10 grand for a crappy seat right now.
Yeah.
Oh.
They
No, but
resale.
you're not getting a box, you're not getting a
The
box.
box weren't even on the market,
It's
sure. They probably just went straight to the spot.
10,000 straight. You're not getting
yeah.
boxes on the base.
Really?
They got scammed, yeah. They could have.
100.
Probably just went straight to like RBC and Rogers and they just like divvied them up.
Yeah, probably.
Oh shit, damn,
Yeah.
nice, sick. How much did you spend for it?
180.
No.
And you know the funny thing, I
On the secondary market?
No, my friend won the lottery, so all of it kind of did it together.
I'm sad that we weren't better friends at that point.
You know, you would have gotten a ticket because I gave it to him.
Yeah. I know so much about this story, and I'm
$100.
really reminded whenever I hear it. It's coming to Toronto about your traumatic. Yeah, a lot of things.
I just checked, so the like front row seats, like right next to the stage, those are going for $34,000 US.
That's crazy.
This is primary, right?
This is, I don't
Second.
know.
No, nothing's primary. Where everything's secondary. I think they've all sold early.
Yeah, my 13-year-old sister said that she wanted Taylor Swift tickets for her birthday last year. And I was like, let me get you something else.
How about a shirt?
Yeah, right?
So 6 concerts at a list 60 to 70 each concert. They say 55 per concert. I think they could squeeze more. They got 60. Let's go 60,000. 6 times 6, 360,000 seats. That's 10% of the population of Toronto.
People are coming from everywhere though.
Yeah.
Why to Toronto? Why would it come to
I've
Toronto?
seen
Wherever
Texas
they can
plates,
get
I've
the
seen Alberta plates, I've seen all kinds of
I
people driving really far.
I heard
Just
someone-
cars.
trying to make a case online that it was cheaper to buy tickets in Buenos Aires.
Oh,
That is accurate.
Flying there, going to the show there and coming back, like hotels and everything.
I believe it.
That's like the liver transplant in the US, right?
you can just fly to Costa Rica, get one.
There was a really absurd
Turkey is
statement.
the country to go to.
So to get a liver transplant in the US, it's actually, somebody did the math. I don't know if it's true. It's cheaper to fly to Spain, get a liver transplant in Spain, live a year in Spain, do running of the bulls, get your liver pierced, buy a bull, get another liver, and then fly back to the US for less than a liver transplant in the US. And somebody did the math, and that's how it's over $100,000.
Sounds like freedom to me.
So whenever you really plan on drinking a lot, just book a Spain trip.
I mean,
But you can
I
still
don't
save a
want
lot
to
of
talk
money.
about it. This is actually very dark.
Yeah.
Glad there's still a live stream.
But I still want to go to the US. It would be fun. It'd be like living.
Yeah,
on it.
just-
No,
just how many
dude,
places
make
you
a
got?
crap ton of money in this stage. Just don't get sick because they're all good.
Or you get a job with good health insurance.
Need a new liver.
Yeah.
Doesn't add up. There's lots of people that deny for expensive stuff even.
Okay.
So I guess we'll continue now.
Just real quick before we start, does anybody want one more slice of veggie pizza?
I do,
You do?
but I'll have it later.
No, you eat it now or I eat it now?
Well, you can have it now.
Have you completed?
That's it.
Excellent.
So we're going back to the 6 experiments that they did. To start with, I guess we'll go to the results because the results are up here. So these numbers here are the number of successful tasks that they solved. We can see that the fine tuning plus the test time training got 29. When we don't add the transformations, we end up having like, 1/6 of the amount of data. And so to train on, and so we only get 13. The E to E data, this is something that I have here. So with this setup here, we can see that when we're generating the LoRa, we end up putting the 3 examples in the language model and then getting a prediction. And then we take the loss of those 2 to create the LoRa. Does this make sense to people?
Yep.
Okay. This is called the demonstration loss. When we have, there's the other way of doing this is,
Sorry, how does the demonstration loss differ from normal loss?
well, so the demonstration loss is used to create the LoRa for,
Okay, but how is it like different? Like, what's demonstration about it?
well, because we're demonstrating the examples and we're getting
Okay.
the demonstration based off the 3 examples that we have.
Okay. And how does that differ from normal loss?
I guess it is a type of normal, like the normal loss would just be something that was applied.
Okay, because I just hear demonstration loss and I think why.
Yeah. But the reason why I'm doing that is because they do one that has no demonstration loss.
I
So
see.
we'll get to that later. The other one is this here, which is the baseline. What they end up doing is they end up predicting y, like y0, and then they take the difference between. So they'll actually, this will be a prediction, and this will be the actual. And then what they'll do is they'll get the loss between the prediction and actual. And they'll add that, they'll make that into the LoRa adapter. The reason why this is different to this here, because this one here has these examples which end up, like we can see here that we have the 3 examples in context. With this one here down here, we only have the language model having the 1 example.
So it seems like it would be basically impossible to guess X1 if you just have X0. So I need some examples to tell you like what the rule is.
That is a good point, actually.
I think maybe they only do it after the first pair.
Yeah, wait, what? Because if we go to here, instead of taking the in context task setup, we use end-to-end task formulation as described in 3.1. For comparison to the test time in context learning approach described above, we also evaluate a test time end-to-end learning approach. We create a supervised data set directly from the example demonstrations by treating each input-output pair as an independent training instance. Unlike the in-context learning setup, no context is used in the prediction. Note that this would be equivalent to leave n-1 out tasks set in ICL settings, as no training examples are provided in the as context. As no training examples are provided as context. I think the difference between this is that it doesn't have. Wait, how is? Yeah, because if you're not given an example of the thing to complete, how do you complete it? You can, I guess you can still take a loss from. This did make sense at some point. This is a good point. How do you take a loss between the baseline?
I mean, you can't just give it the input and ask it to.
Yeah, and then take the difference between the prediction and the actual.
Yeah,
Yeah,
it's not making a guess for the answer. It's just saying, what does the model give it now?
yeah. So you're generating the yn, and then you're taking a loss between the prediction and the actual, even though you haven't given it any examples.
Yeah, because it'll still come up with something.
Yeah, I guess and I guess that's the baseline.
But if it comes up with something.
Like, it'll probably be better than random, but, you know, I wouldn't expect it to be very good.
Because you're only trying to figure out how to build the LoRa, right?
Yeah. Well, I guess this is the yeah. Right, because I guess with this one here, you're seeing if it's doing
Because I thought the upper one had them in context. And, well, there's also the transformations, which are not the baseline. But is it just that?
so Anthony is also downstairs. I thought that he was joining can you get someone else in?
Sure. Huh? The pizza's over. There's no point in coming.
I should say.
You're about 20 minutes from done, aren't you?
Yeah, that's true.
I'll
go bring them up, but still.
Yeah.
I'll still go for drink that.
Yeah, that's true. Yeah, I guess this is something that ChatGPT told me at some point, which is going to be interesting. What did it say? Law of loss, and the xn to E to E ablation in this case differs primarily in how the updates are structured. E to E set up the independent updates. The LoRa updates are applied for each input-output pair separately. That is, for each pair xn, yn, the loss is computed independently as LoRa updates based on that. Oh, right. So I think the difference here is that when you have so what Chris said, you have the prediction, which is just from this, and then you're still getting the loss between the prediction and the actual, and then you're fine tuning it so that if it ever has that pattern, it ends up giving this output.
That's good for memorization, but.
Yes, but I think that the point of it is that they're trying to do it as a baseline to ablate the in context learning.
I see. So like we're seeing how good it is compared to that really bad
Yeah.
method. Oh, that makes so much sense.
So that is that. We have the end-to-end learning tasks, which was that one. We also now have our, what else is it? E to E shared TTT. So this is the same. See how here we're creating a LoRa for every single example that we're given? The difference is that instead of doing a LoRa for every single task that we're given, we make one LoRa for every single, like the entire ARC AGI test set. So this is sort of meaning that we have.
So to be clear, you're saying we put the entire test set into one really big matrix?
Yeah.
And we take the LoRa of that?
Yeah.
But how do you fit that into one big matrix? Do you have like each row?
No. So the LoRa weight updates for this are based on the loss for just this example.
What is the matrix that we're doing LoRa on here?
So this is the entire model that we're still doing LoRa on.
Okay.
But the difference is that the weight updates in the full thing are the weight updates for this one. We've got one LoRa per task.
Okay.
So like, here's this question, and then the model will go and generate the LoRa for that question.
Okay.
When we're doing shared TTT, we end up getting all of the data of all of the examples ever, and then we're creating one LoRa, one update, so one new model for that instead of one new model for every single example.
And so like when you turn the LoRa and then we un-LoRa it, right, in order so we can get like the actual new weights, right?
Yeah.
So wouldn't that would be lossy though, right? Because we would take the model, we would LoRaify it, and then you get this like compressed one and make a change on it. Then we un-LoRaify it, and then like that's lossy, right?
No, they're just matrices that you stick in the middle, right?
Yeah, like converting something to a LoRa is lossy because there's less value.
No, it freezes the base model when you do a LoRa, and then it adds these adapters.
On the
So
top.
it's-
Yeah, so the matrix that comes out of the LoRa
Okay.
gets added to the existing weights. It's
Yeah.
not replacing them.
Okay.
Yeah,
Took me a while to get done.
so like so you can think of a LoRa as a small weight updates added to base model. And in the actual, when we're doing the standard one, we do standard is one LoRa per task, and one task being like, if we go to Arc AGI, just to here, like, this example here would give you one LoRa when you're asking the model this question. So when you ask the model this question, you get a LoRa out of that. This shared TTT is something that you will, instead of doing one LoRa per task, you're doing one LoRa for the entire model for every single example you fine-tuned on.
What's a shared TTT?
A shared TTT is yeah. So the test time training is you basically have one LoRa per question that you're asking.
That's how I would summarize this paper in one sentence.
Yeah.
They're looking at ARC prize questions. They're taking the 3 examples to train a LoRa.
Three at a time or one at a time?
Three examples for each question. So
Okay.
one question, 3 examples.
In the training set,
Yeah.
And so they're training a LoRa just for each question individually.
yes. And
I
then
just feel like give it the.
how do you evaluate though? How do you pick which LoRa it's for each test question?
Because you're with a test question like this here. For the test question here, you put this into the context. You put this into the context, that into the context, this into the context, that into the context.
Yeah.
And then, well,
No, but if you have one LoRa for each question,
yes,
and then like how do you choose which LoRa?
because the LoRa is based on the context of the question. So
So there's like a similarity thing.
no. So when I'm calculating the LoRa, when I'm generating the LoRa, I'm calculating the LoRa to minimize the loss in context when I'm asking this question.
The LoRa is just used once. So you give it the 3 examples of question and answer.
Oh,
And then
okay.
they train the LoRa on those 3, and
Okay.
then only give the LoRa the actual question that they don't have the answer to generate an answer, and then they throw it out.
Cool.
Yeah.
Good summary. Thanks for catching up.
Yeah.
No problem. This demonstration loss is a little confusing, but I think if we go back to this here, did I end up doing a no demonstration loss? So yeah, the no demonstration loss is I think not updating, so not putting the LoRa in that, but still using the in context examples. So the loss still exists, but it's from the test examples. And if we go back to the previous page, these are essentially, this part's confusing. Yeah, so we've got this one here, which is the loss for the demonstrations, I guess. I'm gonna leave this to the end because I think this was confusing when I was going through it the first time, and so explaining it right now is not going to be very good. But anyway, yeah. So they're the results that we get, which is accuracy on different data and optimization ablations in TTT. Our data ablation studies reveal that the ICL, which is the in context learning data format, is crucial for effective test time training. And applying transformations to augment the test time training data set notably enhances performance. In optimization ablations, learning task-specific adapters significantly outperforms using a single adapter. So that's this one here versus shared TDT. Additionally, taking a loss on the in-context demonstrations provides a minor performance boost, while using quantized law results are only in a slight performance decrease drop. So the no demonstration loss is like not doing the LoRa for the test time training. So it's doing all of the fine tuning and everything else, but it's not applying the in context learning where we're then doing the loss. Yeah. Are there any questions about this?
What's E to E data?
E to E data is so instead of taking the loss between like this predicted and actual with all of these ones in context. Wait, there was the E to E is you're essentially putting in the input, you're getting a prediction output without any other context, and then you're minimizing the loss between this prediction and the example that you're given.
Mm-hmm.
It's so you're actually not given a rule to learn in context. It's just used as a baseline to show that it's not very good, but it still has the fine-tuning aspect of it.
Did they do any ablations on like rank size for the LoRa or anything like that?
I don't think so. The LoRa rank is set to 128 and adaptations are applied to the MLP attention and output layers. We train models with the AdW optimizer with 2 epochs with batch size of 2.
Okay,
Yeah.
that seems like something that could make a paper out of is modifying those numbers.
That is true. I have not played around with LoRa stuff very much, to be completely honest, so I wouldn't know how that ends up.
Well, the rank just means how big the matrix is, pretty much.
Yeah.
So 120 is actually pretty big, but you can try with it.
And that just like reduces or like increases the amount of resolution you get when you're low rank adapting.
Yeah, it increases like the number of parameters you're learning, number of weight updates.
That makes sense. The next part that they go to is the like voting. So they do an ensemble predictions. We employ the hierarchical voting strategy to determine the final prediction from the test set candidates. This approach involves 2 stages of voting progressively narrow down the best candidates, first by selecting the most frequent predictions within each transformation, and then by conducting an overall vote across transformation-specific candidates to identify the top 2 most frequent predictions. The details of each stage are as follows: intra-transformation voting. So this is essentially you do a prediction, you then like rotate it, you take another prediction, you then rotate it again, you then take another prediction, and then you hope that, and then you take a voting between the 3 or 4, however many you have within the transformation, and then you take that top one. Row-based majority for each row in the predicted output grid, we take the most frequent row values across all predictions in the transformation group. I am actually not exactly sure what that means in that case.
I think it's pretty clear what's happening. Like you have the you have the input and then you try, like, you do the thing normally and then you do it again, but everything's rotating.
Oh, and then you rotate
And
it
then
back.
you do it again and then again.
Yeah.
Yeah, and then you rotate the run back and then like, if they're all the same, that's great, you go with that, otherwise you just do.
Oh, right, okay.
This is like super specific to RKGI, this is not a
Yeah.
general strategy.
Yeah. This is, so then these are used to predict the output grid, with rows or columns. Okay. Number 2, global voting. We using the selected transformation specific candidates obtained by 1, we conduct an overall vote to select the top 2 most frequent predictions for submission. In the case of retired predictions with the identity transformation are given priority. So that is just that gives these ones where we're like adding these rotate and transpose like transformations, and then we're doing a hierarchical voting, and that gets to 29. 32 with the oracle is essentially like if the correct answer is in the solution, in the set of answers that you could possibly give. If it's in there, it will choose the correct one, and that gets 32. So we can see that the hierarchical voting ends up being pretty good.
If the correct solution is in there, wouldn't it get it nearly 100% of the time?
As in with oracle voting, or with
What is Oracle though?
oracle voting is just like it's a comparison of how high the score could be if you had a theoretically perfect voting schema.
So it's just isolating the effect of
I
being able to generate.
I see.
things
So like regenerate, so like
Yes.
so the Oracle is saying if the correct one was one of the options.
Yeah.
Okay.
Yeah. Does anyone have any questions about that? Flattened versus hierarchical, there is a difference which I did outline here. Which is right where yeah, so like hierarchical voting is this one here. So you have like a rotation group where you've got prediction A and B, then a flip group C and D, and transfer group E and F. You then do a voting within the group. So like what is prediction A versus prediction B, and then this group then gives out a prediction, and then the flip group gives out a prediction, and the transpose group gives out a prediction, and then you take the voting of all of those. With the flattened voting, you just take all of them at once and have one single voting stage. So that's the difference between flattened and hierarchical. Yeah. And then there's a whole bunch on fine tuning. The thing to know about fine tuning is they essentially generated a whole bunch of data from another data set. I'm not going to go through this because this gets into a whole bunch of like jumble about like, you know, they do a whole bunch of different transformations on it to generate even more data sets. They end up having 6,426 generators, and a generator is a rule set that will like map an input to an output. So they're things like rotate 90, and then like, you know, take something from left to right.
So the generators are ways of creating new questions.
Yeah, exactly. And so once you have a generator, you can essentially put random dots on the grid and then get the output state.
And those are just relatively simple pieces of code
Yes.
that it's trying to guess.
Yeah. And the results are this here. So we can see that the tasks solved like without any fine tuning, just with test time training, we get 9. With I'll read this part. Figure 7, left accuracy when fine tuning on different data sources. When all fine tuned models perform similarly, their performance after test time training shows considerable variance. As expected, removing geometric transformations from the fine tuning data set data reduces performance compared to the model trained on the full data set. Surprisingly, excluding LM generated data from fine tuning actually outperforms the model trained on all data. Right performance results across different model sizes. As expected, the performance of the base fine-tuned model improves with increasing model size, aligning with current scaling law trends. However, the scaling behavior after test time training is less clear. For instance, the final performance of the 1B and 3B models is identical after TTT. That the final performance of the 1B and 3B models is identical after TTT.
Yeah, it's the right.
Oh, right. That makes sense.
I mean, it makes sense in terms of what the chart says, but I don't, doesn't
Well-
make sense, kind of unintuitive in terms of what they're observing.
That is true. Maybe there's something there that doesn't. Yeah, I'm not sure. How does, I'll continue this part because I guess this is interesting. How does fine-tuning data affect test time training? We compare models using different fine-tuning data in Fig 7. We find that the model trained on re-arc with a rule-based augmentation achieves the strongest performance. Surprisingly, including LM generated tasks hurts performance by 5%. So this is when you generate language model, you get a language model to generate more training data. Apparently it doesn't generate very good training data, indicating that current LM-based task generation methods may need more sophisticated filtering mechanisms as used in Lee et al. 2024. Finally, we find that fine-tuning performance shows little correlation with test time training performance. Model size and scaling in test time training, we show that the results using different model size in Fig 7 increase the model size consistently improves fine-tuning performance, with the 8 billion model achieving the highest accuracy of 36%. We also observed that test time training effectively closes the performance gap for smaller models, with the 1B and 3B models achieving similar accuracy after test time training. So yeah, open question. Why does that make a difference? Are there any questions, queries, comments?
Have there been other uses of LoRa's for text models? I've only seen them with images, but I assume there is.
It's very common for fine tuning to use LoRa's in language models because you're not
Yes, yeah.
you don't have the risk of model collapse. I'm not gonna go over a whole bunch of this. Like, I guess the thing that they show in this table is that they're better than everyone else, and we sort of already knew that,
Give them the $1 million prize.
right? So Bark is like another paper that introduced another like synthesis, I don't know, another model. Yeah,
Best human, 97.8%.
yeah,
That's what I was saying last week, like RKGI is supposed to be like mostly solvable. And yeah, 60% is the best we got with language models.
I mean,
But I think
Wait, best human, what does that mean? Like human,
Like
like
that's about 97.8% correct, yeah.
I think like the
an
RKGI.
average human or an intelligent human?
no,
I think that's the max.
It's
So the average human is 60%.
I think it's everyone that tried the ARC. I'm guessing it's everyone that tried the ARC AGI public evaluation set on their website.
I think they actually did a formal thingy where they like actually asked people like, here are a bunch of problems, do all of them in order to like get that information.
I think the key part is that every problem has been solved by some human, but no human has solved all the problems.
97.8% of them
Close.
solved by one human.
Close, yeah.
Okay, but so this, what you're saying is this model is as good as your average person,
Slightly better.
Yeah,
give or take, a margin of error.
yeah. For this very,
For that niche task.
For
So that
this
is-
very niche tab that
this-
we've explicitly
yeah.
trained the model.
and not even explicitly trained the model, but explicitly made inference intentionally more complicated so that it could get an artificially high score at inference time on this question. Yeah.
And got,
It
so
counts.
ultimately,
Francois Charlotte would be, you know, I don't like completely irate at the fact that a machine was able to beat the average human.
when it's hyper trained on the exact problem set that are given,
Yeah.
which still means that it is pretty much far out from actually being useful.
Yeah.
But worth,
So all they
Good
need to do is
Just create a neural network at that point, right? Like, why even bother with LLMs?
Well, because they're trying to get towards the general use case, but
But it doesn't,
no.
and I think this concept of training a LoRa for a specific problem at inference time could have merit.
Oh,
Agreed.
definitely, yeah. Like training a LoRa is not super intensive. You can do it on like an 840 sometimes, like
Yeah.
a very cheap thing. So yeah. But for what problem would you
Sure,
want this? It's doable, but it's like very expensive. Like what problem merits something like this? I have no idea.
When there's $1 million prize, it's some silly puzzle.
Yes, yeah. Sorry, I have my business point. I don't, I mean, I'm thinking about like industries. None of
But I mean, research has to figure it out before you industry even
definitely,
gives
yeah,
a shit,
yeah.
right? So this is, I mean, unfortunately, there's a statistic out there that 99% of all research is useless.
Yeah.
It tells us what the dead ends are.
Which study give you that number?
Yeah.
Was it 99%?
There's been some,
I believe.
there's been some work, like a lot of the like citation reference and things like that. Like there's one paper that is cited by 100 million people and the rest are cited by 5 people,
Yeah.
the social group.
Yeah.
So you kind of can massively extrapolate this, right? But you gotta try the dead ends before you're gonna find one that's not a dead end. This is definitely in the dead category.
You think it's a dead end category? It could end up being useful if like training LoRa's and we had a really small language model that training LoRa's on it was actually like computationally efficient, but.
LoRa is not a dead end. I think LoRa in trying to solve the logic problems.
Yeah.
I think this is, I don't see this as being a successful. I mean, it's opened up some ideas and people might derive something more successful out of this, but I mean.
Well, I mean, in the conclusion, our findings suggest that test time methods could play a pivotal role in advancing the next generation of language models. So yeah.
The big challenge for the next person, right?
And the other thing is you could have, here they're just training the LoRa and throwing it away.
Can you keep it?
But yeah, I mean, if it's, there's something between training the LoRa for one specific question and then throwing it away versus like training the LoRa that becomes a character that you use for everything. I don't know.
Well, they ablated that, I guess.
But that's all in the context of the archive.
Yeah, that's,
Oh, right.
maybe not.
Oh,
So let's
right,
take a real world-
as in like every in context learn, like you almost do back prop on all of your context whenever it goes in there, and then you're constantly updating the model.
Like imagine maybe for your kind of curriculum bot,
Yeah.
you could have a LoRa for each customer that gets updated relatively frequently for the things that they see, and then that's how you have the model of what they've learned. And
Or just your power users. You
yeah,
know, like if you have users that use a lot of an application.
Yeah. The problem though with that sometimes is if it's a chat-based interface, you don't want to do backprop over the text that the model output, I guess, because you can end up getting into interesting scenarios there. Unless you have some other signal that tells it whether or not the current chat is a good chat or a bad chat. Because
Yeah, which I assume would be the case, like if the query got resolved or something. Or in most chatbot, or like if it's like customer service, usually like if it gets to the point that they have to refer it to a human, that's bad. Right?
Yeah.
So could have something.
Yeah, so that's the paper.
Since I missed it and we have like 2 minutes, I think, can you show me how they represented the problem in text?
Yes, it's right.
I'm sure they did like what others did. I'm sure they're not like came up with it.
They did find it.
So each color is not to a number?
Yep.
Okay.
Which I also don't really understand this
Yeah.
because it's a single, this is a single array within another single array, not a single array for each row.
Yeah.
So, yeah.
Fair point. But also, why does it have to be numbered? Why couldn't it just be like Y for yellow or something? like
That is a good point. That is a very good point.
you could even just use each of those colors. There's 9 colors. Each of those colors is its own token.
Yeah.
that you could just.
Special tokens,
Because
yeah.
distance doesn't matter in this case.
But you're also
But this
using.
is just one token. It's not letter to letter. It's just
No, but
blue
like,
is a token, yellow is a.
Yeah, but
So
with the
instead
number,
of-
with the number anyway, like in language models don't have a concept of distance between.
Yeah.
No, what I'm saying is like black, green, yellow, orange, pink. Those will each be one token.
Yeah.
So it's the same number of tokens.
Oh,
You
to
had-
say yellow, orange, the
Yeah.
textual representation.
Yeah.
I guess it may be because if you use numbers, you can output format it really nicely.
Another thing is they're doing this on existing models, like if you want to use, it's hard to train a model to use different tokens, I think.
Well, I guess he's just saying that like black, the primary colors are most definitely already their own tokens in all of the
Yeah.
models anyway, and so why not just use them?
That could have even been another.
So I actually have a conspiracy theory on this.
Yeah.
Code is like roughly 25% of the pre-training corpus for most language models, if not more. And my guess would be you want it to think like it's a lead code problem or some kind of coding problem. So if you kind of convey it like it's a math or like when you give it a matrix of numbers, it's like maybe got its like math logical thinking on, like maybe that's something from.
You are a world-class leak code expert. Trying to get a job at a tech company.
Yeah. Honestly,
they
maybe
still do that.
What?
they
Yeah.
do lead code, yeah.
Do they still?
People, yeah. People still do, yeah.
Yeah, they. Still
No,
do.
like, as part of the hiring process.
Yeah. It's insane, I think.
It's a little stupid, yeah.
It's only about the first thing.
It's only gotten worse.
Yeah, because then it's more competitive. It's more competitive because everyone's cheating, and so because everyone's cheating, there are more people applying.
Yeah.
Yeah.
It's basically, are you willing to cheat for this job? That's what it's filtering.
Yeah.
Historically, it was filtering for something completely different. But
Yes.
That's what I'm saying, is still, it seems to have been compromised.
Yeah.
As all techniques that are once good, people figure out how to compromise them.
What's the if the benchmark?
Yeah, that's when you have a single target as your goal, and that goal, that benchmark becomes useless after a while, yeah.
Exactly, because you're over optimizing that rather than. And that's kind of the point of this, right? The whole point of logic is you cannot optimize for specificity. If you're specifically optimizing and that you're not actually solving the logic problem.
But Alex, you don't understand. A number on graph go up.
No, number go down, loss go down, therefore.
Yes.
The question.
Fair point.
It also would be interesting to see if there's some. I guess that the class of question are questions, if there's some classes of that does well, it does not.
True.
But once you train on a logic problem, not on logic, you've kind of self-defeated yourself.
Yeah, but I guess the difference is that the logic problem is like always going to be a proxy for the logic. And
Yeah,
as soon as you need to formulate a question around it, you're choosing a format to do that in. And so as soon as you're doing that, then there's some way to game it.
Correct.
Yeah.
It's just like reducing everything to the SAT problem, right?
Yeah. Well, that's what I was asking about early, is if there was some way of converting art problems into real world problems. And it seems like no.
Unless you want to game the Mensa test.
yeah.
I'm sure that most language models probably got very high on the Mensa test anyway.
Mensa, no,
Really?
because it's problems like this, it's logic problems.
It's all like 140 IQ. It's not even just like a normal IQ.
It's
I mean, I guess.
it's a normal IQ test and you have to score top 2%. That's the whole point of it, but
Yeah.
it's all logic capability. So A is to B is B is to what?
Yeah.
Which I'm assuming logic, unless the problems are recycled, I would assume that even the linguistics one, this thing would fail terribly. It could be interesting. The only problem is if you Google those kind of questions and plug it into this thing, I think it'll do very well. Not because of it understands logic, but it's repetition on something that's already been trained on.
So we know those examples.
Sorry?
We know the examples.
These examples here
Which is why they're visual.
are examples task generated by LM data augmented procedure. So this is when they're trying to generate data using language models that didn't end up. So we display 3 reasonable tasks that we can infer for simple translations, and 3 tasks that we could not infer simple translations. And these are the valid ones that thing we ended up coming up with.
Wait, they manually infer? Like we can infer a simple transformation? They
Yeah.
manually checked?
I
Kind of crazy.
guess, yeah.
Wow. It's a lot of
And then
work.
these ones here are invalid for some reason.
Because it's like, I can look at them and you can't figure out any simple rule.
Yeah, that
Yeah.
makes sense.
Some of them just seem wrong. Like there is a rule, but it's not applying it correctly.
Mhm.
Yeah.
It'd be interesting to see how they generate it.
Yeah, I mean, honestly, all this work just to find out that it worsens performance by 5%, I would be livid.
Yeah.
These-
Oh, here we go. Here's the,
Problem
You-
generator.
you are a problem generator on a 2D grid of colors. Here are some examples of such transformations. Please follow the format. Example, description of the generator function, script generator function. And then please generate more examples, more, and make sure that they are different. So this is getting them to generate these generators here. Where like the generate function is the thing that creates the rule, and then applying the rule to a input like grid will then generate the output, which I guess is cool. Yeah. These are the, oh, here we go.
Everywhere, please do not use their terms of transformation pattern recognition.
Yeah. That is.
I'm trying to give you guys.
No, I'm just. There is the augmentations that they use to the data, to the generations. They do things like rotate, flips, reflects, random translates, transposes, and everything like that. And then they do things. So these are, the thing about these is that they're inversible, like invertible. So you can apply them and then apply them again, and they'll go from one to another. Or you apply the invert. Yeah, this is sort of it. That's the paper. Because to catch it up. That is, does anyone have any questions, queries, comments?
What, did you go through this?
It's very math heavy.
Sorry?
It was very math heavy.
Yeah, it was.
Ooh, math.
It had, the thing about it that was difficult about this paper to go through is that it had so many things that it did, that it wasn't like normal papers are like, we're, you know, they're like normal scientific papers are like, we're changing this one thing.
Mhm.
And because we're changing this one thing, here's how that impacted all the other things. And so it goes through the hypothesis and theory and all the results and everything. This one here is like, we're changing 6 things. And here's all of the 6 things that you need to look out for, which ends up being one of the reasons why I don't really like reading model release papers, because they end up being marketing, and this is definitely marketing. So yeah.
How is this definitely marketing? This is more of a victory lap because
That's true.
they got the highest score.
That is
So
true.
it's more of a victory.
Yeah, but it's a victory lap, and it's marketing for their victory lap, I guess.
True, yeah, it's marketing for them. It's like,
Yeah.
hey, look how great we are.
Like, I don't think they really care about that. It's not like they're working for Google. They like, it's just from people at MIT. They're not trying to advertise MIT.
No, they
Oh, yeah, they are.
yeah. No. They're thinking that they're trying to advertise themselves, which is how any AI research goes at the moment.
I see.
Which is like,
Please hire us. We are good.
yeah,
Yeah.
I'm gonna start.
Look at great result. Yes.
Yes.
We only use $1 million in compute to solve a silly little.
Well, they actually, no, so
We're better than humans.
interestingly, the compute that they used was, they only used a amount of, wait, they had it in here.
Offer is looking for jobs, so I see why he, yeah.
What is it? It was,
Oh, he's open to work?
Yeah, like this is the first offer. He's on the job market apparently.
yeah. So they said,
Okay,
With the whole
an A100 isn't exactly cheap.
yeah,
No, it's not. Well, they probably own the A100, so it's not so bad, right?
Is
with
that
like the
bad?
whole TTT inference process takes approximately 12 hours for 100 randomly sampled
Wait,
validation.
it took
tasks.
12 hours for 100 questions?
I guess it did.
So they don't own it. They're renting it at Amazon.
That's not that bad though.
No, why do you say that? Just because they have the hours?
Yeah.
No, they might have just counted how long they were using it.
It's like.
Oh, okay, it's like a shared university.
Yeah, like they have it like probably have like a Slurm job scheduler or something. and
Yeah.
like Provisions that Slurm. I just like saying Slurm.
I have no idea what that is, but yeah.
It's just like it's like if you need a GPU, you just ask it, give me one GPU, please.
Oh,
and it gives
yeah.
it to you. It gives you whatever's free.
You can like rent an A100 for $1.64 an hour, so. it's like-
Yeah, so it's
Oh, okay.
$12.
So it's within
Yeah.
hobbyist level, they're
I just
not,
have
they're not some like,
No, but it's
No, I
not
was
like
looking
because they
at
did it for only 100 questions. That's
Right.
not good. 100
Yeah.
questions. How many is? Do you know the total number of questions in the data set?
they said they had 6,000 generators. Wait, how many?
6,000 A100s? That's not okay.
But
Project,
6,000 12-hour cycles on an A100.
Is it like a Kubernetes? farm?
Yeah.
I
not okay.
have no idea. I just click the button and I get a Jupyter notebook.
Oh, that's really funny. 12 hours on 100 randomly. Fine tuning steps are a whole other thing.
training happened on the ARC data set with approximately 600,000 generated tasks.
Oh. my
So-
God.
They're interesting. It seems like.
Oh, theirs doesn't even count. It had to be within 12 hours.
So I think this is the inference step, I guess.
Yeah, that definitely is the inference step, but it still didn't count for the leaderboard. These guys were just doing it for the love of wasting energy.
But if they once they've fine-tuned the model on all of the things, I guess that's the question, how much did the fine-tuning step cost? Because the inference step doesn't matter as much.
They trained up to 16,000 steps with 2x A100s, 4x A100s, and 4x A100s. I mean, that has to have been a long time because they trained for a lot of tasks. I don't think they give the specifics though, unfortunately.
You only give the specifics if it advantages you.
Yeah, yeah.
Otherwise, it's just,
If they're trying to get hired, they don't want to write, yeah, we used 500 grand of like GPU hours to do this. Okay, let's do the math. Let's do the math.
That's for the specific thing, fine-tuning phase.
$192.
One-
On the back.
But this is
Pressing X to doubt. I am doubting that.
pure model,
Wait, how's it doing? Looks cheaper. 400 tasks, 12 hours. No, it's misunderstanding. It says 12 hours per 100 tasks. But the 12 hours was for 100
inference.
things.
Yeah,
Inference, yeah.
we already know that language models can't do math very well, so let's.
Yeah. Well, estimated cost between 8 to 10,000 is like, I feel like it's still very low, but even that is like pretty beefy. It's not cheap in this economy.
Yeah.
just to help everybody with the joke, you can add that statement to the end of absolutely anything you say and it still works.
Yeah.
Right, like just
In this
take any random statement, put in this economy as a suffix and it will make sense.
Yeah.
During the boot times as well?
Anytime, because it doesn't matter where the accent is, it could be positive or it could be negative.
True.
And therefore that.
Or it could just be stagnant. Oh, we're good.
Same thing, right? Like,
Yeah.
I want to eat pizza in this economy.
Yeah, literally.
There's absolutely no statement that will not work with that suffix.
That's funny.
Their code, their repo is actually quite nice, honestly.
Yeah.
Which is,
What's the link to that?
it's if you search the surprising effectiveness of test try.
Found it. It's,
Abstract
yeah, I
reasoning,
found that.
which is nice, honestly.
That's so cute that they think people are actually gonna run it themselves. Like we all have like.
No, but if they're looking for a job, their marketing does not.
Yes. Yeah, definitely.
You don't want to put a shit repo because some developer who has no idea what's going on is like, oh, this guy doesn't know what he's doing. So you got to clean up the repo and make it look decent.
Yeah.
Which is actually. So they've got the predictions.
I want to see something like this done, but for one of the small LMs, like the actual small LM. I think that's the org name. and they just put
Well,
out
this,
LLMs that are like,
the smallest one that they have is a 1 billion parameter model.
yeah, I want to see 100 million or something, see how well that
That'd be
does.
cool. That'd be cool.
And you can LoRa for longer maybe, because it's cheaper to do on a smaller one. I don't know. It'd be cool.
Oh, like increase the amount of LoRa, like the precision of the LoRa because you have
Yeah.
less parameters.
Yeah, you have less parameter stuff that you can do. You can try different things, maybe bigger patch size, I don't know,
That's cool.
something like that.
Yeah.
So dumber model, more specialized training.
Oh,
That would be
interesting.
Yeah.
Yeah, so that was today's session, folks.
Are you gonna play the song?
Which one?
Hey,
Oh,
Laura?
the, sorry?
What LoRa song?
Laura.
I want to hear this LoRa
No,
song.
I don't want to call, I don't